Hello everyone, welcome to a physical science lesson. We're going to be looking at relationships, and in particular we're going to focus on graphs as a method for describing these relationships. So let's take a moment not to do some maths, but to do some good physics and chemistry by looking at the features of graphs. So here we go. When we look at graphs, we recognize they can be used to describe different relationships. And these are all the relationships that we've spoken about previously. A directly proportional relationship, a squared relationship, an inversely proportional relationship. But when we deal with graphs, there are some skills that we need. And these skills relate to the plotting of graphs, the sketching of graphs, and interpreting of graphs. Now, we're not going to be able to do all of those skills, but we're going to focus on them one at a time. So let's begin by looking at what it takes to plot a graph in physical science. And here are some points to follow. So when you are drawing a graph, one of the first things you've got to do is you're going to look at the data. That will normally be given to you in a table. And you've got to recognize within the table that there are independent variables and there are dependent variables. And you need to make sure that you understand the difference between an independent and a dependent variable. Can you remember what those differences are? Well, if you said that the independent variable is the one that you control, then you're right. The dependent variable is the change that you observe because of what you have done in an experimental situation. All the other variables are constant. They are the control variables. That's what makes it a fair test in an experiment. So be aware of what the independent and the dependent variables are. Now, when you are looking at the data, you have to decide what the heading is. The heading is usually related to your hypothesis. And it will relate your variables to each other and describe them in detail. Now, some people are quite static and they don't give much detail. They'll say something like velocity versus time. I prefer to be more descriptive in my heading, and I'll show you an example shortly. So please remember that you can earn a lot of marks and you can gain a lot of understanding from a graph if you put all the bits and pieces together. The heading is one of those. The other is that you need to label the axes. So when you label the axes, you need to make sure that there's always a unit included. So here's a sort of outline of what I've just said. For any graph, we need to recognize, mostly in science, we look at only this quadrant. So it's on this side, there are positive values, and on this side, there are positive values. And that's what we're going to be looking at in terms of the area that the graph occupies. The independent variable, with an SI unit attached to it, is the one that you would control in an experiment. And because it's the independent variable, I want you to understand it's always written on the horizontal axis. Now, I don't like to say x-axis and y-axis. That's for maths. For physical science, whether it's physics or chemistry, the horizontal axis could be the time axis, or it could be the volume axis, or it could be any of the other variables that we might want to look at. But so I refer to it as the specific one that we are dealing with. And it's important that we use the SI unit with that. There are only some exceptions to that rule, and those particularly occur with time. Sometimes instead of using seconds, we might use minutes, but we don't often use hours unless the experiment is carried over a very long time. So, if the independent variable is at the bottom, the place where you dive in, okay, the swimming pool, you dive in at this side, then this is where the deep end is. The deep end is for the dependent variable, which is on the vertical axis. Please always put the SI units there, and put them in brackets so we've got it very clearly stated. So make sure you can identify the variables, and in the heading we're going to say the heading will be described by something about the dependent variable and then in conjunction with the independent. So we usually say dependent variable first, then the independent. Now, I know this is all quite generic and quite theoretical. Let's go and look at a practical example so you can see exactly what I'm meaning. So if we are given the idea of a graph showing the distance a person walks in a certain time interval. Now, the word distance is the output. The thing that we are measuring or controlling is the time interval. So time is the independent variable, and the distance measured in meters is the dependent variable. And so that's how we set up the graph. If you do just that in a 6 or 8 mark question, you know what? You can almost get 50% of the marks just by putting those things that I've got on this little sketch graph in place. Sometimes it's 40%, sometimes it's 50%, but we want to make sure that you get, for a graph in question, as close to 100%. So what are the other details we need to take note of? Can you think what we might need to be very careful about? I'm sure you said something about selecting the scale. Now, unfortunately, this is an area that a lot of learners struggle with, because on a table of values, they're given a whole lot of data, and it might not even be ordered. The first thing to do when you look at your table of data is to order from either smallest to biggest or biggest to smallest. Doesn't really matter. I usually like it to go from smallest to biggest. And then you've got to decide how that's going to fit in. So you look at your graph and you say, what's my lowest value? What's my highest value? And then you've got to do some clever thinking as you look at your piece of graph paper. So your graph paper for selecting scale will be one like this, where you've got blocks and you've got lines, and you'll see these are the bigger lines, and then you've got these smaller lines that represent different units. Now, the scale on this is very evenly divided. It's every 2 seconds. So that's 2, 4, 6, 8, 10, 12, 14, 16. And you'll notice that the independent variables are measured, because we are controlling them, they are measured equally spaced apart. Now, this isn't always true. What is important, though, is that you recognize that you can't just put the numbers onto the different blocks. So you can't go 2, 5, 7, 8, 15, just because that's what the numbers in the table are. If it was 1 to 15 or 0 to 15, you're going to have to say, let's count up the number of blocks we've got. In this case, you'll see I've got 1 big block, 2 big blocks, 3, 4, 5, 6, 7, 8. Now, that's a bit of a funny one, because if I look at 8 and I say 8 multiplied by 2, that will give me 16. So I can make each big block 2, just like I've got it here. And that will allow me to fit in my numbers. But they won't be one after the other. They'll be spread out at equal spaces between them. And so my values will not be jumped together. They'll be spread out. Very important for you to know. Now, if we look at the vertical axis, we also recognize we need to have a scale here. In this case, the scale is the same for the horizontal and the vertical. It doesn't always have to be like that. But again, we've got to recognize each of the values are at regular intervals. And so one block here represents 2 meters, and another block represents another 2 meters. So 2 meters plus 2 meters is 4 meters. And that's how it carries on going. Now, I want you to see that in this case, we've been able to plot some points on the axis, and we're going to talk about those point plotting things. But before we get that, I want you to notice these points cover the majority of the graph. They're not constricted to a small area over here, or they're off the page. We've only got a few of them. So it's very important when you choose your scale to make sure your graph doesn't look like this, with points just over here. You want to make sure they fill most of the space. So if we do that, we must make sure that we select the appropriate scale. One of the ways of doing that is to change the actual data. So sometimes the data could be very small, and instead of writing it as it's given, we can say times 10 to the 15 or times 10 to the minus 3. And I'll show you an example of exactly that as we look a little bit further. I think I missed that, but on here, there it is. I've put the distance as times 10 to the 6 because you see it's the distance a rocket moves in a time interval. Now there are two more critical points when we talk about how to draw graphs accurately that you need to take note of. And those are the idea of plotting points and the line of best fit. Let me give you some tips about plotting points here. So it's very important related to scale that you can see that you've got a certain number of blocks between here and here. In fact, there's 1, 2, 3, 4, 5. So that means that 1, 2, halfway through 2, that will be 1. So what is each small block going to be? Well, if you work it out, it's 2 divided by 5, which equals 0,4. So each of these small blocks equals 0.4. So it's 0.4, 0.8, 1.2, 1.6, and then 2. So when you come to plot a point, you mustn't guess where something is. If the reading is, for example, 1.65, well, then you must be as accurate as you can to actually put the point into place. So you always start with the value that's on the independent variable and you match it to the value given on the dependent variable. So, for example, if the value that I was given was, I want to find the point that is giving me a value of 1,4 as an independent variable, and let's say 2,4 as a dependent variable. How am I going to put the 1,4 on? Well, I'm going to say it's not there. It's not there. It's halfway between those two. So I'm going to do a line up here, and it's going to go to 2,4, which is all the way up there. So it's halfway in the middle there. Don't make too big a dot, and then come across here, and you'll see that we've gone up the one block, which is 0,4. So that's why we know that this value here is 1,4, and we can put a colon there to say 2,4. And you've got to make sure every one of your points is plotted accurately. And again, I've made that dot quite big so that you can see it. But when you're doing it on graph paper with a pencil, you always plot with a pencil on the inside of the graph paper. You never use ink. You can use ink down here at the bottom, but never on the inside. The labels are all in ink, the headings in ink, but the plotting is in pencil. And make the dot as small as possible. Right. I think that helps us with plotting points. Now we're talking about the line of best fit. And if you look at this line, you'll see it doesn't actually look too straight. Here's the temptation, is that some people will take a ruler and try to join point to point. That's not how we do it in physical science. You might do it in life science like that, where the variables aren't actually discrete points, or they're not a continuous thing. They're separate measurements, something like a patient's temperature or a plant's temperature over time. It can vary. It can be a broken line graph. But when we're doing it, even though it looks jagged, we take our ruler and we try and get a line that fits through the majority of the points, and it will look something like that. You'll see some of the points are not on the line. That one is slightly below, this one is slightly above. The difference between the line and where the point is, that can be measured as a bit of the error. Because in every experiment, there might be some error, human error or what we call experimental error. Now, we don't only get points that fit on a straight line. You can use your ruler to see that it's a straight line. But you can also get points like this. Now, I could say, well, the straight line looks like it could be somewhere over there, and we'll ignore those points. Or we could say we take the straight line like that. That's not the way to do it. You've got to look at the whole set of points as one big picture. And then you've got to draw a freehand line that fits through the majority of them. So to do this properly, we're going to erase all of those, and let's put the line in as accurately as we can. And I'm going to just do something like that. And although it's a little bit wobbly, with practice you'll get better, and make sure that you can see the shape of this graph looks a little bit like a parabola. Well, guys, I wish you well. You've got to practice in drawing graphs, and it is a very important idea, but there's so much more to learn about graphs. But first of all, let's go to a short break.